Myself Gurnath Kalibermal, Assistant Professor, belong to Aeronautical Engineering from Srinivasan Engineering College, Perambalur. Now I am going to explain about Euler's equation. This is an equation of motion in which the forces, say gravitational force and the pressure forces are taken into the consideration. Let us assume a cylindrical element having the cross-sectional area of dA and length of ds is in a streamline flow. That flow is happening in the direction of S. On this element, the gravitational force will be acting towards the earth surface, which is W, which equals mass into gravity. The mass of this cylindrical element can be obtained in the terms of density into volume, dA into ds, and gravity. If we move to the forces, the pressure forces acting on this element in the direction of flow, P dA is the pressure force acting. Opposite to the direction of flow, pressure plus change in pressure within the element dou S into the distance, elemental distance ds and the dA. Now, in order to obtain equation of motion of this, we can consider the Newton's second law, which states force equals mass times the acceleration. You know, force equal mass into acceleration. With this Newton's second law, we can correlate the forces acting on this element. The forces are, say, let us consider the forces acting in the direction of flow as positive. So, P dA, this force is acting opposite to the flow direction, minus of P plus dou P by dou S into ds of dA. This body force weight also acting opposite to the flow, so we can say, which is making inclination of theta. So I can write this equation as minus rho dA ds g cos theta, which equals mass into acceleration, where we can simply say cos theta, if you magnify this portion, so this is ds and this is dc, the datum head. From this we can say cos theta is nothing dc by ds. So I can replace the cos theta with the term dc by ds. When come to the acceleration, we know where acceleration is change in velocity with respect to time. If you consider the velocity, if you take the velocity is the function of the distance s as well as time. So this acceleration can be written in the form of, which equals dou v by dou t plus dou v by dou s into ds by dt. If the flow is steady flow, if the flow is steady, then the dou v by dou t will become 0, and this ds by dt is nothing, the velocity. Change in distance with respect to time is velocity. For steady flow, this dou v by dou t will become 0. So this acceleration can be simply written as ds by dt is velocity, then dou v by dou s. This is the acceleration. Now, with the consideration of acceleration and cos theta is nothing dc by ds, this equation can be written as, with the simplification of these terms, this PdA will get cancelled with minus PdA. Then we will have, when this minus gets in, minus dou P by dou S into ds into dA minus rho dA ds g cos theta from here is dc by ds, dz by ds, which equals mass is nothing, mass from here rho dA ds, mass is rho dA ds and its acceleration is v dou v by dou s. Now if I divide this equation with the term rho dA ds, in all the term we have ds dA. I am going to divide this equation with rho dA ds. Then this equation will be in the simple form minus dou p by dou s 1 by density minus rho dA ds gets cancelled, g dc by ds which equals v dou v by dou s. If I bring right hand side term to the left hand side, all will become negative. Straight away I can consider all this term as positive. Say 1 by density dou p by dou s plus g dc by ds dou c by dou s plus v dou v by dou s which equal 0. In all these three terms we have dou s. These are in the partial differential. In the differential form we can write this equation simply 1 by density into dp plus g dc plus v dv v dv which equal 0. Simply the sum of pressure head, datum head and kinetic head is nothing, 0. So this is the Euler's equation of motion. Thank you.